Okay, so for today, we will discuss regarding pumps. So pumps, the purpose of a pump is to transfer a fluid from a region of low pressure to another region at the same or higher temperature. Pressure, sorry. So a machine which is used to add energy to a liquid in order to transfer the liquid from one point to another point of a higher energy level. So pump then is a device used to move gases, liquids, slurries, so from lower pressure to higher pressure and overcomes this difference in pressure by adding energy to the system such as water system. So meron tayong two different types of pumps, positive displacement and dynamic. So under ni positive displacement, meron tayong rotary, reciprocating, and linear. So si positive displacement traps confined amount of liquid and forces it from the suction to the discharge port. So ito siya. So yan yung three types of positive displacement pumps, rotary, reciprocating, and linear. So sabi, si positive displacement daw, itatrap niya yung liquid and it forces it from the suction to the discharge port or it produces pressure by creating flow. So si rotary pump, pwede siyang maging gear pump, vane pump, and screw pump. So ito yung three different types ni rotary. Si gear, si screw, and si rotary vane. So while si reciprocating, plunger, diaphragm, and piston. Si dynamic naman, may centrifugal and special. So si dynamic, impellers, or kinetic. Yan. So impeller pass on velocity from the motor to the liquid which moves the fluid to the discharge port. So ito naman, it produces flow by creating a pressure. So ito yung sa centrifugal, direction of flow. So alam nyo na to, radial, axial, and mixed. So description, so discharge radially or tangentially along the outer radius of the pump casing or 90 degrees turn to outward. While si axial, fluid enters and leaves axially or parallel. So si mix naman, intermediate between centrifugal and axial, some angle between radially and axially. Pag sinabing radial, pag meron siyang radial flow, ang pressure niya is high, ang discharge flow rate niya is low. While si axial, merong low pressure and high discharge. While si mix, it's relatively high, pareha sa pressure and discharge. Wait, para may kulang na slides dito. Saglit lang ah. Iba. Okay. Okay, so balik tayo dito sa rotary. So si rotary pump, so fluid flow happening through the casing whenever these gears are rotating. So a discharge will be created no matter what discharge pressure is. Si reciprocating naman, a definite volume of liquid is trapped in a chamber. So meron tayong piston and cylinder, which is alternatively filled with from the inlet and emptied at the higher pressure through which discharge. Pag sinabi namang linear type, the fluid displacement takes place linearly or in a straight line. So the system is quiet, vibration-free, and offers the advantages of easy maintenance and a long operating life. So ito yung difference ng tatlong types ng ating pump. So si rotary, si reciprocating, and si linear. So pag sinabing screw, gear and rotary vane, so dito sa tatlo, so yun lang yung nasa loob nitong casing natin. Ayan. Typical pump installation, we have, so meron tayo ditong lower reservoir and si upper reservoir. Meron din tayong suction pipe or pag PS siya. So check valve, gate valve, and pressure gauge. Meron din tayong discharge pipe. So si continuity equation, magagamit din natin dito yung volumetric flow rate which is Q is equal to area times velocity. Meron din tayong total head or the total dynamic head na tinatawag or the sum of the heads, elevation heads, pressure heads, velocity head, and yung ating frictional loss. So kinetic energy and velocity head. So kinetic energy is the ability of mass to do work by virtue of its velocity. So the kinetic energy of a mass having a velocity is 1/2 mv squared. So ang elevation head or elevation energy. So in connection to the action of gravity, elevation energy is manifested in a fluid by virtue of its position or elevation with respect to the horizontal datum plane. So yun namang pressure head or yung ating pressure energy, a mass of fluid acquires pressure energy when it is contact with another masses having form of energy. So pressure energy therefore is an energy transmitted to the fluid by another mass that possesses some energy. So total energy of flow is the sum of the energy or the sum of the head in a fluid. So kinetic and potential energy. So recall that potential energies are sum of pressure energy and elevation energy. So, kaya ganito yung ating total dynamic head. So, meron din tayong pump efficiency or the water power or the pump work is equal to specific weight of the fluid times the volumetric flow rate times the head. So, meron din tayong brake power. So, pump work over the efficiency. So, over the pump efficiency. Meron din tayong specific speed. So specific speed is equal to speed square root of discharge over volumetric flow rate over h raised to 3/4. So ito gagamitin nyo to pag English unit lang yung given. So pag SI unit naka-indicate naman dyan kung ano ang gagamitin yung formula. So next, impellers. So pag higher heads, meron daw tayong low specific speed. Pag lower heads, meron daw tayong high specific speed. So in RPM, impeller would operate to give 1 gallon per minute for a total dynamic head of 1 foot. So meron din tayong classification of pump based on suction lift. So yan, up to 25 feet. So shallow well pump, deep well pump up to 120 feet, turbine pump up to 300 feet, and submersible is for higher head. So, reciprocating pumps uses a piston and cylinder arrangement with suction and discharge valves integrated into the pump. So, meron tayong relief valve, discharge, suction, and yung ating piston and cylinder. So, alam naman natin na ang movement nito is, kumbaga nagpa-pump tayo. So, actually, di ba? So, yan. Pag sinabing reciprocating pumps, discharge, so, ang ating discharge is low. Meron tayong high head and low speed. So, additional information for reciprocating pumps. So, in new pumps, slippage is within 2% and it is commonly used as the boiler feed pump for steam and can be double acting or single acting. So, can be simplex, duplex, and triplex. So, meron din siyang air chamber. It is uses to smoothen the flow due to the nature of flow of the liquid. So, this is placed either on the suction side or discharge side. So, ito yung sinabi pag triplex, so meron tayong 3 drive rods. So, pag duplex, meron lang tayong 2. So, yun yung difference between simplex, duplex, and triplex. So, yung kanyang drive rods. So, characteristic of reciprocating pumps. So, meron tayong piston displacement is equal to, if rod is neglected, 2 times pi over 4 times d squared over L times N. So, ang L dito is yung length and yung N is yung ating speed. So pag rod is considered, VD is equal to pi over 4D squared ln plus pi over 4D squared. So diameter, outside diameter minus inside diameter times L times N. So meron din tayong slip or yung ating slippage is equal to piston displacement minus the volumetric flow rate. So percentage slip or slippage percentage is equal to piston displacement minus volumetric flow rate over the piston displacement times 100%. Meron din tayong volumetric efficiency is equal to Q or the volumetric flow rate over the piston displacement. Or pwede natin, pag given ang percent slip, ima-minus lang natin siya sa 1 para makuha natin yung volumetric efficiency. So, pag sa rotary pumps naman, so, ang difference lang nito is yung nasa casing niya. Sa loob ng casing, pag sinabing internal gear pump, so ganyan yung itsura, external, lobe pump, and yung vane pump. So, gear pump, it moves a fluid by repeatedly enclosing a fixed volume using interlocking cogs or gears, transferring it mechanically using a cyclic pumping action. So, vane pump, a positive displacement pump that consists of vanes mounted to a rotor that rotates inside a cavity. So, in some cases, these vanes can have variable length and V tension to maintain contact with the walls as the pump rotates. So, pag sinabing rotary pumps, meron tayong low discharge and meron lang tayong low head. So, ang other types ng rotary pumps, depende nga dun sa nasa loob ng casing, screw, cam and piston, and shuttle block pipe. So, for centrifugal pump naman, so a pump in which pressure of centrifugal force. So, it converts kinetic energy into pressure energy through diffuser vanes. So, si centrifugal pump is one of the example or the type of dynamic or kinetic pump. So, pag sinabing dynamic ulit, impellers pass on velocity from the motor to the liquid, which moves the fluid to the discharge port. So, it produces flow by creating pressure. So, magkaiba si positive displacement and si dynamic. Pag sinabing positive displacement pump, it produces pressure by creating flow. Pag sinabi namang dynamic, it produces flow by creating pressure. So, sa centrifugal pump, so meron tayong high discharge, low head, and high speed. So, meron din tayong pump affinity loss. So, sa centrifugal pump, pag sinabing same pumps, tapos constant daw ang diameter, variable speed. So, Q, siya yung ating volumetric flow rate. N ay yung speed natin. H1 is yung ating head. And yung P is yung ating pressure. So, yan yung ating affinity loss. So, pag constant speed, variable diameter, so Q1 over Q2 is equal to D1 over D2 raised to 1. H1 over H2 is equal to D1 over D2 raised to 2. And P1 over P2 is equal to D1 over D2 raised to 3. So, pag lang yan ay centrifugal pump. Meron tayong pump affinity loss. So, meron pa rin tayong constant speed, variable density. So, density naman siya in terms of density kung kanina ay speed. And yung isa is diameter. Yung nasa baba, meron din tayong density. So, equal lang lahat siya. Q1 over Q2 is equal to density 1 over density 2. Head 1 over head 2 is equal to density 1 over density 2. And pressure 1 over P2 is equal to density 1 over density 2. So, ito siya. Para madali niyong tandaan, Q. So, magawa lang kayo ng table. QHP and D, then 1, 2, 3, 1, 2, 3. So, type of affinity loss. So, itong 1, 2, 3, 1, 2, 3 is ito yung kanyang exponential power. So, yan. Pag naman gusto mo, halimbawa, ang objective mo is to increase head. So, ang gagawin mo sa pump, instead na siya ay parallel, i-connect mo siya in series. So, para siyang sa electrical, sa EE, 'di ba? Sa electrical wirings, ganon. Series and meron pa series and parallel sa pumps. So, kung ang objective mo is to increase head, i-connect mo siya in series para maging head ay H1 plus H2 plus H3 and so on. Pero ang kanyang volumetric flow rate ay equal sa lahat. Kung ang objective mo naman is to increase the discharge or the volumetric flow rate, so i-connect mo siya in sa parallel. So, ang magiging head niya ay equal, kahit ilan pa yan, kahit 10 pa yan, H1 is equal to H2 is equal to H3, up to 4, ang head niya is equal. So, ang volumetric flow rate naman niya, kasi nga, ang objective mo is to increase the discharge or the volume flow, Q1 plus Q2 plus Q3, and so on. So, ano nga ba ang difference between the positive displacement pump and the centrifugal pump? So, meron din siyang advantages and disadvantages. So, for centrifugal pump, so yan na lang. I-screenshot nyo. Basahin nyo lang. So, high pumping water volume, while si positive displacement is low, meron lang tayong low pumping water volume. So, si centrifugal pump, low maintenance required lang siya. So, meaning, pag low maintenance required, low lang din yung ating cost. May kakaunti lang yung magagastos natin. Mailabas natin pera para ma-maintenance siya. While sa positive displacement, medyo malaki ang kailangan nating pera and malaki yung cost ng maintenance niya. So, sa centrifugal, high efficiency, that is degraded when the pump deviates from rate speed, while si positive displacement naman, the pump is able to operate efficiently over a wide speed range away from the rated speed. So, sa centrifugal pump naman, the pump can pump water with low solar radiation by using PVPS. So, si positive displacement requires high starting torque to operate by PVPS. So, the pumping flow rate varies accordingly to the pumping head. Pag sinabing centrifugal, while si positive displacement, the pumping flow rate is approximately equal, regardless of the pumping head. So, equal siya. So, as the water viscosity increases, the flow rate decreases. So, yun ang sa centrifugal pump. So, si positive naman, displacement, as water viscosity increases, flow rate also increases. So, directly proportional yung kanyang water viscosity and si flow rate. So, si centrifugal pump, widely used in PVPS and rarely used in PVPS naman si positive displacement pump. Next one, pump selection process. So, considered pipe sizing and motor power requirements before selecting the pump. So, una is yung pipe daw. So, for example, sige. May example naman dyan, pero ang ano lang dito is Q is equal to area times velocity. So, halimbawa, given yung flow rate. So, sasabihin sa'yo ni customer, gusto ko ang pump ko is ganito yung flow rate. Halimbawa, 5, ganon, 5 meters per second or 10, yan. So, 10 feet, 3 to 10 feet per second. So, yun na yung example, di ba? So, ngayon ko, computein mo, Q is equal to area times velocity. Then, yung velocity ko is ganito dapat. 5 feet per second. So, ngayon, kinompute ko yung Q is equal to area times velocity. Kinompute ko yung diameter ng pipe. So, ang diameter ng pipe lumabas na ay 9.1 inches. So, dun sa 9.1, wala ka namang mabibili na 9.1, di ba? So, pag ang binili mo naman 9, so, hindi niya kumbaga kulang yung flow rate na malalabas. Kasi 9 lang yung binili mo, may 0.1 pa na kulang. So, ang gagawin mo, pag magse-select ka ng pump, is ira-round off mo. So, ira-round off mo, 9.1, gagawin mo siyang plus 1. So, 10 inches. Ang bibilhin mong pipe size or yung may diameter na 10 inches. So, gagamitin mo lang yung Q is equal to area times velocity. So, sasabihin naman sa'yo na itong kailangan kong volumetric flow rate, itong kailangan kong velocity na lalabas. So, ano ang kailangan kong uh, pipe diameter size? So, kukumputin mo lang yun using the continuity equation or the volumetric flow rate, which is the Q is equal to area times velocity. Then, kahit anong makuha mong sagot, halimbawa, 9.05 inches. So, 9.05 inches, i-round off mo pa rin yun. Magpa-plus ka pa rin nun ng 1. Kahit yan ay 9 point, halimbawa, 9.0000005 inches, so, magpa-plus ka pa rin ng 1 doon. Gagawin mo siyang 10 inches. So, yun yung ating pump selection process. Mag-add up tayo ng isa. Next one, net positive suction head. So, dito sa NPSH, since cavitation occurs when the absolute pressure of the liquid reaches its vapor, so it is obviously that the phenomenon is intimately related to the pump suction head. So, the suction head, HSV of a pump, is the equal total head at the pump center line corrected for vapor pressure. So, sinasabi lang dito, so kung kanina, balikan natin itong isa. Oops. Nasaan na yan? Ayan. So, mapapansin niyo dito kanina sa total dynamic head, which is elevation head ng discharge minus elevation head ng suction plus pressure head ng discharge minus pressure head ng suction over the specific weight plus velocity head ng discharge squared minus velocity head ng suction squared over 2 times gravitational acceleration plus the friction head loss. So, ito nga yung TDH, di ba? Total dynamic head. Kasama yung discharge. So, discharge and suction siya. So, ito yung Bernoulli's equation. Diba? So, in-add up lang yan. So, ginawang total dynamic head. Dito sa NPSH, so mapapansin nyo, coming from the word itself, net positive suction head. So, suction head, meaning sa suction lang tayo titingin. So, lahat ng head, elevation head, pressure head, velocity head ng suction. So, sa suction lang, hindi natin isasama yung discharge. So, yun lang yung ating gagamitin para mag-solve ng problem. Si suction head lang. Okay? So, HS meaning static level or gagawin mo siyang positive or negative if above or below the center line. Meron din tayong HP which is the absolute pressure. So, HP is the absolute pressure corresponding to the surface of the liquid from which the pump draws, or this will be the atmospheric pressure corresponding to the altitude of the unit if the tank is open, or the absolute pressure in the heater or closed tank from which the pump takes liquid. Meron din tayong HZ or HS. So, yun the height in feet of the or meters of the fluid surface above or below the impeller center line. So, meron tayong HF. So, ito yung head loss because of friction, turbulence between the surface of the liquid and the pump suction flange. Meron din tayong HVP. So, ito naman yung head corresponding to the vapor pressure of the liquid at the existing temperature. So, mamaya magpa-problem solving tayo about pumps. So, bakit nga ba need nating isolve itong net positive suction head? Kasi in designing a pump installation and purchasing a pump, there are two types of suction head or the NPHS to be considered. So, yun nga, sa pag kayo ay nagwo-work na, iko-compute nyo 'to pag kayo bibili ng mga pumps and pipes, ganyan. So one is the available suction head of the system and the other is the required suction head of the pump to be placed in the system. So the former is determined by the plant designer and it is based upon the condition of the liquid handled, the pump location, and etc. The latter is specified by the pump manufacturer naman, and it is usually based upon the test results of the pump or a similar one. So, ito, necessary that the available head of the system, okay, be equal or greater than required suction head in order to avoid cavitation difficulties. So, makikita nyo, NPHS available or the net positive suction head available must be equal or greater than the net positive head or net positive suction head required. So, katulad din yan ng pump selection process, plus 1, must be greater than. Okay? So, dito sa net positive suction head, greater than or equal, dapat yung available suction head natin kaysa sa required in order to avoid cavitation. So, alam naman natin si cavitation. So, yun yung phenomena na deteriorate o nasisira, na damage yung ating pump. So, it is very important role ng net positive suction head. So, sa proper selection of both centrifugal and positive displacement type of pump. So, this pump has its own specification for the same. So, the absence of available or sufficient NPSH. So, pag naging less than to, less than yung available sa required, it will result in cavitation. So, mare-reduce din yung ating pump efficiency as well as its performance. So, it reduces pump reliability as well as the internal parts constantly seek replacement. So, dahil nga na cavitation. Ano nga ba si cavitation? So, is the spontaneous vaporization of the fluid resulting in a degradation of pump performance. So, the formation of cavities of water vapor in the suction side of a pump due to low pressure. So, pag sinabi cavitation, if the pressure at any point inside a pump drops below the vapor pressure corresponding to the temperature of the liquid will vaporize and will form cavities of vapor. So the vapor bubbles are carried along with the stream until a region of higher pressure is reached and they will collapse or implode with a tremendous shock on the adjacent walls. So yun yung pumuputok yung ating vapor bubbles pag dumaan ng high pressure region. So yung pinakita ko last time sa inyo. So, ano nga ba yung causes ng cavitation? So, una, ang discharge head far below the pump head at the peak efficiency. Next one, meron daw tayong high suction leaf and low suction head. Meron din tayong excessive pump speed and high liquid temperature. So, in order to prevent cavitation, so meron din tayong 5 na steps. So, increase the height of the fluid surface, reduce the friction and minor losses by shortening the suction line or using a larger pipe size. So, kaya tayo ay nagpa-plus 1 para ma-reduce din. Di ba? Pipe selection process tayo. So, nagpa-plus 1 tayo para mas malaki din and para ma-prevent din natin yung cavitation. And third one is to reduce the fluid temperature at the fluid entrance. Fourth is pressurizing the fluid supply tank and reducing the flow rate or the velocity. Oh, okay. Magpa-problem solving na tayo about pumps. Oh, wait lang, guys. Ayan. Okay, ayaw mag-open ng aking open board. Saglit lang, ah. Sige, guys. CR break muna. So, balik kayo ng 9:50, 9:50. Then, kuha na kayo ng mga calculus. Okay? So, sige, balik mo, CR muna kayo. Okay, so nakikita na ba ulit yung screen ko? And
Yes po, ma'am.
okay, so for this sample problem number one, water in the rural areas is often extracted from underground water source whose free surface is 60 meters below ground level. The water is to be raised to 5 meters above the ground by a pump. The diameter of the pipe is 10 cm at the inlet and 15 cm at the exit. So neglecting any heat interaction with the surroundings and frictional heating effects, what is the necessary power of the pump for a steady flow of water at a rate of 15 liters per second in kilowatts? So dito sa mga pumps, iti-try muna nating pag sinabing ah, naka-raised sa above the ground. So, iti-try muna nating i-drawing sila. Wait lang. Okay, yan. So, okay. Ang sabi dito is 60 meters below the ground level. So, for example, meron tayo dito. Okay na ta. Ground level. So, ito siya. Yan. Or meron tayong ground level to. Ground level.
Ma'am, excuse po.
Yes. Nawala ba?
Pure black lang po naka-display sa amin.
Oh my God. Hindi talaga. Sige, sige. Saglit lang. Ulitin kayo, sir. Ayan. Kita na ba? Or pure black
Yes
pa
po.
rin?
Kita na po.
Okay.
Thank you po.
Sige. So, ayan. So, water. So, ulitin ko sa sample problem number one. The water in the rural areas is often extracted from underground water source whose free surface is 60 meters below ground level. So, the water is to be raised 5 meters above the ground by a pump. The diameter of the pipe is 10 cm at the inlet and 15 cm at the exit. So, neglecting any heat interaction with the surroundings and frictional heating effects, what is the necessary power of the pump for a steady flow of water at a rate of 15 liters per second in kilowatts? So, ito, for example, ito-drawing natin yung pump natin. So, ano nga ba ang itsura ng pump or kung nasan yung kung ano yung height. So ito yung sinasabing underground water source. Saglit na. Okay, hindi na naman mag-ano yung akin. Ang ayaw talaga. Yan. So ito yung ating sinasabi na 60 meters below the ground level. So ito, for example, ang ating ground level. So gagawa tayo ng pump. Ayan. So meron daw tayo dito. Ayan. Sorry, pangit. Pipe. So So, magkaiba yung ating pipe sa inlet, pipe diameter sa inlet, and pipe diameter sa exit or sa outlet. Okay, ang sabi dito, it is extracted, it is extracted from the underground water source. So, underground, whose free surface is 60 meters below the ground level. So, meaning, yung ating pump is 60 meters, yung ating inlet, pipe inlet is 60 meters below the ground level. So, ito ay 60 meters. Okay, ano sabi? The water is to be raised 5 meters above the ground by a pump. So, ito yung pump natin. Pump. And, tataas down natin siya ng yung water ng 5 meters above the ground. So, ang diameter down ng ating inlet. So, ito yung inlet. Nandito. Kasi kukuha nga tayo ng water sa underground na 60 meters below the ground level. So, meaning ito yung ating inlet diameter or D1 na 10 cm. And yung ating pipe diameter at the outlet ay 15 cm. So, ngayon, ang power or yung ating kinocompute is yung power ng ating pump. And meron din daw tayong volumetric flow rate na 15 liters per second. Okay? So, tayo ay given. Maglalagay na ng mga given values. So, meron tayong H at the suction is equal to 60 meters or yun yung ating H1. So, ngayon, ang ating H at the discharge is equal to 5 meters. And yung ating diameter ng ating inlet or sa suction ay 10 cm. So, i-convert na natin into meters. So, 0.1 meters. And yung ating diameter at the discharge ay 15 cm or 0.15 meters. Tapos, neglecting any heat interaction. So, hindi tayo magsasama ng mga frictional losses natin. And meron din daw tayong volumetric flow rate na given, which is the 15 liters per second. So, i-convert na natin to into cubic meter per second. So, siya ay 0.015 cubic meter per second. So, ang required is C or the unknown ay ang ating water power. Water power or yung ating yan. So, maalin dyan yung ating gagamitin. So, kung anong mas gusto nyo. Sige, WP na lang. water power. So, pag sinabing water power, yung kanina, YQTDH or yung ating specific weight of the fluid times the volumetric flow rate times the total dynamic head. YQTDH. So, ito lagi nyo itong magagamit. So, kailangan tandaan nyo to. So, meron tayong specific weight kasi constant water. Q meron din, which is yung given value natin na 15 liter per second. And ang i-compute na lang natin is si TDH. So, kanina si TDH, meron tayong parang sa Bernoulli's elevation head, HS minus or HD minus HS plus yung atin namang pressure heads. So, siya ay PD minus PS over specific weight plus yung ating velocity head, which is velocity at the discharge squared minus velocity at the suction squared over 2 times gravitational acceleration. So, hindi na natin isasama yung ating frictional or yung ating frictional losses. Pero kung wala to, neglecting any heat interaction with the surroundings, so isasama nyo siya. So, since naka-indicate naman dito sa problem na ina-neglect natin, so hindi na naman natin siya isasama. So, ito yung total dynamic head, where elevation head plus the pressure head plus the velocity head. Okay? So, ngayon, meron ba tayong elevation head at the discharge? Yes po. Ito po, 5 meters minus yung ating suction head na 60 plus yung pressure natin. So, meron bang pressure na given? So, wala po. Diba? Walang given na pressure. So, pag walang given na pressure, meaning, ang gagawin natin is, sabihin natin na ang pressure niya ay 0 or constant. Okay? So, in-neglect na rin natin yung ating pressure. Neglecting pressure. So, since wala namang sinabing pressure, so meaning, wala siyang change in pressure. Then, velocity head. Meron tayong velocity head na galing dito sa volumetric flow rate and sa ating diameter, pipe diameter sa inlet and sa outlet natin. Okay, so gagamit tayo ng continuity equation para ma-solve yung ating velocity at discharge and velocity at the suction. So, unahin muna natin i-solve yung velocity at discharge and velocity at suction. So, Q is equal to area times velocity. So, unahin natin ang velocity at suction is equal to Q. So, equal ang Q, diba? Q in is equal to Q out or Q1 is equal to Q2 over area. So, 0.15 cubic meter per second over pi over 4. Itong ating diameter for the kina-compute natin. Suction is 0.1 meter. 0.1 meter squared. Tama ba? So, ang velocity natin ay equal sa, at the suction ay equal sa 1.91 meters per second. Okay, so pa-solve na rin. Baka mamaya mali yung pindot ko sa calcu ha. So, try nyo i-resolve habang nag-solve tayo. So, ito yung ating velocity at suction or V1. Ang velocity at discharge naman we have Q is equal to area ulit. So, area at discharge ang gagamitin natin. So, 0.015 cubic meter per second. So, since using continuity equation, Q1 is equal to QT ulit. So, gagamitin ulit natin yung volumetric flow rate na 0.015 cubic meter per second. Pero iba na yung ating gagamitin na pipe diameter. So, sa discharge na siya. So, pi over 4, then diameter ng ating discharge. 0.15 meters. 0.15 meters squared. So, ang ating velocity at discharge ay equal sa 0.85 meters per second. So, check na natin if yung makukuha na natin yung total dynamic head. So, meron tayong HD, given ba yung HD and HS? Okay po, meron po. Check, check. Then, 0 yung ating pressure head since wala ding given na pressure. So, siguro, yan na lang natin na nineglect natin yung pressure pag walang sinabing pressure. Kasi si pressure, pag wala sinabi sa problem na walang pressure, meaning walang change in pressure. So, halimbawa, 1 minus 1, di ba, 0 pa din siya. So, neglecting the pressure head, 0. Then, velocity head, meron tayong na-compute na velocity at discharge and velocity at the suction head. And yung ating gravitational acceleration, constant. So, pwede na natin siyang i-substitute yung ating given values and computed values sa ating formula for total dynamic head. Okay, hindi na naman ano ang aking pen. So, wait lang guys. Yan, okay na ulit. So, yung ating head ng discharge, oops, ay, yan, 5 meters minus yung ating head ng suction, which is 60 meters. So, ito na yung ating elevation head. So, head ng discharge minus head ng suction. So, kasi siya ay below center line, meaning ine-negative natin siya. Okay, kasi siya ay below center line. So, makikita nyo, ito yung ating ground level or yung ating center line or kung nasan yung ating pump, nandun yung center line and yung ating ground level. So, negative siya since below center line siya. So, pag above center line, so siya ay positive. Plus, yung ating velocity head, 0.85 meters per second squared minus yung ating velocity at the suction head. So, yun yung kinompute natin kanina. So, siya ay 1.91 meters per second squared over 2 times gravitational acceleration na 9.81 meters per second squared. Hindi na naman siya ano na. Okay. Okay, so for TDH, meron tayong 64.85 meters. So, na-compute na natin yung ating total dynamic head. Okay. May problema talaga tong aking pen. So, hindi lang dito nagtatapos yung ating solusyon kasi ang unknown sa ating problem or yung ating hinahanap is si water power. So, ito na yung ating mother formula, di ba? Si water power is equal to specific weight times the volumetric flow rate times the total dynamic head. So, since we already computed the total dynamic head, so ito yung HD, so elevation head, discharge and suction, pressure head, neglecting the pressure head since walang sinabing pressure head, walang sinabing pressure, so meaning wala tayong change in pressure. Yan yung ating velocity head. So, computed na din yon. So, na-compute natin yung total dynamic head. Then, pwede na natin siyang substitute sa mother formula which is the water power or the YQTDH. So, water power is equal to Y for the specific weight ng water times Q times the total dynamic head. So we have the specific weight of water, 9.81 kilonewton per cubic meter, times yung ating volumetric flow rate, which is 0.15 cubic meter per second, times yung ating computed na 64.85 na total dynamic head. Itong ating water power ay equal sa 0.015. 9.54 kilowatts. Okay, same ba tayo ng na-compute ni answer? Baka kasi mali ang pag
Same lang po.
Same lang din po.
Same lang po,
Ayan.
ma'am.
Okay. So, may question ba dito sa problem number 1?
None so far po.
Okay, so yun, ganito lang yung sa pumps. So, ingat lang kayo sa values and sa positive and negative. So, yun, yung inyong manual, so may mga activity doon. So, ipapapasa ko na lang yun before midterm. So, siguro mag-aalat ako ng time kasi para mabasa nyo rin yung manual. Kasi yan, medyo late na rin naman. Dahil lalo na nag-online tayo. So, di ba dapat face-to-face tayo ngayon. So, mas pinili na lang natin mag-online. So, yun, laging gagamitin dito sa pumps is itong si water power and TDH. Yun yung lagi kong ah, napapansin sa mga problems. Laging water power, total dynamic head, NC area times velocity or si continuity equation. So, huwag niyong kakalimutan pag nawawala yung velocity. So, kung wala namang sinabi, for example, kung wala namang sinabing diameter, so, ang given naman is pressure. So, ang gagawin natin, si pressure head, nandito, and si velocity, since walang diameters, so wala ka makukunan na velocity head, so siya naman yung zero. Kasi wala meaning, walang change sa ating velocity. So, ganun lang dito sa pumps. So, medyo madali lang naman talaga yung fluid map. Ganyan lang. So, tapos yung YQTDH or D specific weight times volumetric flow times D total dynamic head. So, para makompute yung ating water power. So, ito yung madalas na ginagamit na formula. So, ganito lang yung set of questions for pumps. So, paulit-ulit lang na ganyan. So, malilito lang kayo kung positive or negative. So, yun yung common mistake ng iba na nag-i-interchange yung value. Nagiging negative 60, yung iba nagiging positive. So, kaya nagkakamali yung iba. Okay, so next question tayo. Yan. Sample number 2. So, a pump delivers 500 gallons per minute of water against a total head of 200 feet and operating at 1,770 RPM. Changes have increased the total head to 375 feet. At what RPM should the pump be operated to achieve the new head at the same efficiency? So, kanina meron tayong pump affinity loss. So, meron daw tayong head, total head, ang unang pump na 200 feet. Ngayon at even. So, head ng unang pump ay 200 feet. And yung atin daw, speed ni unang pump ay 1,770 RPM. So, ngayon, ang changes daw have increased the total head of 375. So, ang ating head 2 ay 375 feet. At what RPM should be the pump operated to achieve the new head at the same efficiency? So, ang ating required or yung ating unknown ay speed ng second pump. Okay, so meron tayong pump affinity law na H1 over H2 is equal to N1 over N2 squared. So, given naman yung mga values natin. So, we will directly substitute yung ating given values dito sa ating formula. So, ito yung pump affinity loss kanina. So, H1, check. H2, so speed at pump 1, and yung ating unknown. So, 200 feet over 375 feet is equal to 1,770 RPM over yung ating N2. So, ang ating new speed ay equal sa 2,424 RPM. Okay? So, same ba tayo ng answer?
Opo, ma'am.
Okay. So, ito yung pump affinity law. So, ito naman ay yung PowerPoint kanina is isa-send ko sa inyo sa G-Class. Ay, sorry, hindi nga pala tayo makapag-post sa G-Class. So, hindi ko alam kung bakit. So, sa Facebook na lang. So, next problem. Ayan. So, a pump with a 400 mm diameter suction pipe and a 350 mm diameter discharge pipe is to deliver 200,000 liters per minute of 15.6 degrees Celsius of water. So calculate the pump head in meters if suction gauge is 7.5 cm below the pump center line and it reads 127 mm H3 vacuum and discharge gauge is 45 cm above the pump center line and reads 75 kPa. So, ang question dito, so given. Bago pa lang given, isa-isahin muna natin. Suction pipe, 400 mm. Convert natin to into meters. So, siya ay 0.4 meters. Discharge pipe is 350 mm. Then yung ating volumetric flow rate, which is liters per minute. So, siya ay 20. Okay lang. So, in terms of, ano tayo? Times 1,000 liters per 1 cubic times 1 minute over 60 seconds. So, ang bago nating volumetric flow rate sa unit na cubic meter per second is 0.33 cubic meter per second. Meron din daw tayong calculator section. Pressure or suction, calculate the pump head in meters if suction gauge. So, meron tayong suction gauge na 7.5 cm in the pump below the and reads 127 mmHg the vacuum. So, times natin siya ng 760. To 5 kPa. Ang ating P at suction is 16.93 kPa vacuum. Tama ba? Cm below center line report and discharge is 45 cm above the pump. Discharge gauge. Okay, gauge pressure pala siya. And reads P2. $75 discharge. Gawin natin siyang yung ginamit natin 1 or 2. 1. 1, 1. Tama pa? 75 kPa. Tama ba? kPa. Okay. Then, yung ating discharge gate is 45 cm above the pump center line. So, H2 is equal to 45 cm. So, i-convert natin to into meters, 0.075 meters, and dito ay 0.45 meters. So, anong tanong dito ay, ang unknown is to calculate the pump head, meaning the total dynamic head. So, unknown is si total dynamic head. So, si total dynamic head, so H2, or yung ating discharge to kanina, minus H1, ito yung elevation head plus pressure head. Plus yung ating velocity head. Okay? So, tingnan natin. H2 minus H1, mayroon siya. Check. P2 minus P1, given din. So, may change in pressure tayo. And velocity head, may diameter. Okay, meron tong velocity head. Mako-compute natin yung ating velocity head using the diameter and yung ating given na volumetric flow rate. So, check. So, meaning lahat ng head dito, yung elevation head for yung ating elevation and potential and kinetic energy, nandito na lahat siya. Okay? So, i-compute natin lahat. So, wala tayong in-neglect dito. Since nandito na lahat yung ating or given na lahat. So, drawingin na natin yung ating pump para mas maintindihan natin siya. A pump with a diameter of suction pipe. Unahin na natin ang suction pipe. Is deliver calculated from front if the suction gauge is, so meron daw tayo center line, laging uunahin yung center line or yung ating ground level. Yes, center line na lang tawag natin kasi hindi pala siya center line. So, siya daw ay, the calculate pump if the suction gauge is 7.5 cm below the pump center line. So, meron daw tayo 7.5. cm. And sa discharge gauge naman is 45 cm above the pump center line. So, nandito yung ating pump. Nandito yung ating gauge, suction gauge, and yung ating discharge gauge. Then, meron daw tayong diameter ng suction 5, which is 400 mm. So, may nakakonect tayong gauge pressure gauge dito. Then, meron din tayong 350 mm sa discharge pipe. Okay, so meron na tayong pump, then yung mga pipes. So, ang sabi nga dito kanina, yung atin daw suction gauge is 7.5 cm below the center line. So, ito yung center line natin. And meron daw siyang gauge pressure na 127 mmHg vacuum. So, naka-vacuum yan na. Tatandaan nyo, vacuum pressure siya. So, meaning, pag inano natin siya is negative. Then, meron din tayong discharge gauge, the 45 cm above the pump center line. And read 75 kPa. $75 kPa and yung kanina 127, so yung kPa yung kinonvert natin 75 16.93 16.93 kPa vacuum or sabihin na lang natin vacuum. Yes, a negative. Okay, so meron tayong 350 and 400 mm. 0.4 meters and 0.35 meters. So, pwede naman tayo mag-solve using this. So, TDH, using this formula, solution. So, i-compute muna natin yung ating mga velocity since pwede naman natin i-direct substitute na tong elevation head and pressure head. So, itong mga velocity, kailangan natin compute yung velocity niya using volumetric flow rate and yung ating mga given diameters. So, using Q is equal to area times velocity ulit. So, for V1, the velocity at the suction, Q over area 1. So, Q, we have computed 0.33 cubic meter per second over yung ating area. So, may diameter tayo at the suction na 0.4 meters. So, we have velocity 1 ay equal sa 2.626 meters per second. Velocity 2 naman, Q over area 2. So, 0.33 cubic meter per second over pi over 4 times 0.35 meters. So, ang ating velocity 2 ay equal sa 3.429 meters per second. So, since meron na tayong computed velocity, so pwede na nating i-substitute yung ating velocities doon sa velocity head ng ating TDH or yung ating total dynamic head. So, substituting all the values, TDH, so H2, ano bang H2 natin? So, above center line, so siya ay 45 cm. Nasa na siya? H2, ayan. 0.45 meters, 45 cm. 0.45 meters minus yung ating H1. Ang sabi dito ay, diba, 7.5 cm below center line. So, below center line, so, ginawa natin siyang meter, kinonvert natin siya into meters. So, negative 0.075 meters kasi siya ay below center line plus. So, tapos tayo sa elevation head. Pressure head naman tayo. Pressure at point 2 or at pressure at outlet is 75 kPa daw. Minus pressure at point 1, which is, yun yung ating 127 mm Hg vacuum. So, kinonvert natin to into kPa. So, 16.93. So, since vacuum siya, negative 16.93 kPa over yung ating specific weight ng water. Plus yung ating velocities na kinompute kanina. So, V2 na 3.429 meters per second. I'm sorry, meters per second squared. Minus yung ating velocity 1 na 2.626 meters per second squared over 2 times gravitational acceleration na 9.81 meters per second squared. So, ang ating total dynamic head ay equal sa 10 meters. Okay, so wala tayong ni-neglect na values since wala namang sinabi na i-neglect dapat to, and lahat naman pressure, elevation, diameter, and velocity is binigay ni problem. So, kaya sinolve na lang natin ang velocities, then i-direct sub natin sa total dynamic head formula. Okay? Any questions or clarifications for problem number, anong number ito? 3. May questions ba?
Wala naman po so far.
Okay. So, next. Yan. So, NPSH na to, or yung ating net positive suction head. Wait lang. Okay. So, water is pumped from a pump where the pressure is atmospheric to a height of 3 meters. Water temperature is 40 degrees Celsius. So, ang kanyang pressure, vapor pressure is equal to 7.3845 kPa. Loss of head pressure due to friction is 0.75 meters. So, find the available NPSH. So, diba ang NPSH? So, sa suction head lang tayo lahat. So, halimbawa, ako is nagbigay sa inyo ako ng problem. Then, katulad nito. So, yan, sa previous problem. Sample number 3. So, di ba may binigay ako sa inyong mga discharge head values, yung mga discharge pipe diameter, discharge pressure, discharge, ano pa ba? Velocities, ganyan. Elevation na, discharge, ganyan. So, pag tinanong ko lang dito is si net positive suction head, i-disregard nyo lahat ang discharge, lahat ng discharge head. So, meaning, ang i-compute nyo lang is si for suction head, yung ating mga H1 lang. Ang gagawin nyo, 0 si H2, P2 0, B2 0. Kasi, kaya ko tinatanong, kasi nga, coming from the word itself, net positive suction head, magpo-focus tayo sa suction head lang. Okay? So, dito, given naman siya na suction head lang talaga. Lahat yung given. So, H is given. HS, meron daw tayong height na 3 meters. Loss due to friction, so HF ay 0.75 meters. Ngayon, meron tayong vapor pressure na 7.3845 kPa. Find the available net positive suction head. So, required is si NPSH. So, di ba may formula tayo na NPSH is equal to positive negative HS plus HP minus HF. Or yung ating static level above or below the pump center line. So, pag positive ulit, above the center line. Pag negative, below center line. HP, the absolute pressure on the liquid surface of the pump suction supply. And yung ating HF is the total friction head loss in the pump suction pipe fitting. So, meaning net positive suction head is yung ating total suction lift. So, NPSH, HS. So, since siya ay where the pump is at atmosphere from a pump where the pressure is at the height of 3 meters. NPSH is equal to 101.325 minus 7.3845 kPa over 9.81 kilonewton per cubic meter. So, ito yung kanyang HP o yung absolute pressure na liquid surface of the pump suction supply. Ito siya. Tapos, yung ating, ano pa ba? Ito pala, yung HS natin. H is minus. Ay 3 meters. And minus yung ating suction frictional head loss. 0.75 meters. So, ang ating NPSH ay equal sa 5.82 meters. So, ito na yung ganyan lang kabilis isolve yung net positive suction head. Kasi, mag-focus ka lang sa suction head. So, i-disregard mo lahat ng disregard mo lahat ng nasa discharge head. Okay, so any questions or clarifications?
Wala naman po.
Wala naman po.
Okay, so kung wala nang questions or clarifications, so ganun lang mag-solve na mga pump problems. So, Q is equal to, yan. So, ito na yung medyo mahaba eh. Yung water power pa kasi bago ka maka-solve ng water power, isosolve mo muna ang TDH. So, yan. Ganyan lang yung sa pumps natin. Wait, ba't hindi siya ano na naman? Okay. So, basta tandaan niyo lang yung TDH and kung positive or negative siya. Then, compute for velocities. If wala or hindi given, you can use the diameter in yung volumetric flow rate natin. Then, yun na siya. So, meron pa dito na iba pang, pwede pang maging question sa inyo. So, katulad ng mga efficiency, so mga brake power, so yan na siya. Okay, so kung wala nang questions or clarifications, i-send ko na lang sa inyo yung PowerPoint, i-upload ko na lang siya. So, kung wala nang questions or clarifications, so class dismissed. Thank you, guys.